going to be talking about how to rationalize the denominator. Now, we've talked about rationalizing the denominator in the past, back in Chapter 6, and we were dealing with imaginary numbers, because fractions are kind of unique things. I like to look at fractions as being real fragile because they're very particular. For example, when we have a fraction, we should never have a decimal inside of a fraction. So like you should never have 0.5 divided by 4. That's not a proper way to write it. Or you can also never have fractions inside of a fraction. So if you have 3 divided by 2/3, that's not proper. And we learned in Chapter 6 that it's not proper to have an imaginary number in the denominator. So 4 divided by 6i would not be okay. And we talked about how to rationalize the denominator to make it so it was okay. Well, today we're going to talk about the fact that it is never okay to leave a square root in the denominator of a fraction. If there is a square root, we have to rationalize that denominator. All it means to rationalize the denominator is make it so that way it's proper, so that there is no square root in the denominator. It's okay if there's a square root in the numerator, we just never can have one in the denominator. So let's look at this first fraction here. We have 4 divided by the square root of 30. Now these first few examples we're going to look at is going to be when we only have one term in the denominator. We'll look in a little bit what to do when we have 2 terms in the denominator. But for this first one, all you have to do is multiply the top and bottom by the same thing. We're going to multiply the top and bottom by the square root of 30. Now you might say, well, why is that? Why would we do square root of 30? Well, let's look over here for a second. You don't have to worry about writing this down in your notes, but just look at this pattern here. We know that if I take square root of 2 times square root of 2, that's the square root of 4, which square root of 4 is 2. We know that if I have the square root of 3 times the square root of 3, well, that's going to be the square root of 9, and the square root of 9, that's 3. If we had square root of 6 times square root of 6, well, that's the same as the square root of 36, and square root of 36, that's 6. Look at the pattern. Square root of 2 times square root of 2 is 2. Square root of 3 times square root of 3 is 3. Square root of 6 times square root of 6 is 6. So you can see the pattern. So the whole reason in multiplying by the square root of 30 in the top and bottom is, again, to get rid of the square root. So my answer in the denominator is just going to be 30. Now in the numerator, I want you to think of the square root symbol as like a box. That square root of 30 is inside the box. We've talked about that box before. We've talked about the square root before, and we always look to see if I can simplify that by unpacking it, by taking anything out of there. Now, we are not in the habit of putting things into the box. So we do not want to take 4 and put it inside there and say that it's 4 times 30, so it's a square root of 120. That is not what we're going to do here. We never put anything inside the box. We take the 4 and leave it parked outside the box. So it'd be 4 square root of 30 over 30. Now there's going to be some simplifying that we may have to do. Let's start with the radical. The square root of 30, I want to see, well, does that simplify at all? Because we've talked about that in the previous lesson. Square root of 30 breaks down to be, well, we could say 3 times 10. 3 is prime. 10 breaks down to be 2 times 5, and those are both prime. Now remember with the square root, even though there's no 2 there, we're looking for every 2 of the same number, I get to take 1 out. I have a 2, I have a 3, I have a 5. I don't have any pairs of the same number. So the square root of 30 can't be simplified. But the 4 and the 30 can, because 2 goes into both of those. 2 goes into 4 2 times, and 2 goes into 30 15 times. So my answer is going to be 2 times the square root of 30 all over 15. The square root of 30 can't be simplified. The 2 and the 15s can't be reduced. Now you might say, well, what about the 30 and the 15? That could be reduced. But the problem is that 30 is trapped inside the radical. It's trapped inside that box. That is untouchable. The only things that we can touch is what's outside the radical. So that's why we looked over here to see if it could be simplified. It couldn't, so that 30, like I said, is untouchable. We can't do anything with it. But sometimes what's under the radical can be simplified. Let's look at the next one. So think for yourself, what would we multiply by to rationalize the denominator here, to get rid of the square root of 27? Well, you should have gotten that. We're just going to multiply by the square root of 27. And you always multiply the top and bottom by the same value, because essentially we're multiplying by 1 here, because square root of 27 divided by square root of 27 is 1. So we're not changing the value of the fraction. That's important to talk about. Let's go back to the previous one. 4 divided by the square root of 30, if you did type that in your calculator and got a decimal as your answer, we should type 2 square root of 30 divided by 15 and get the same exact decimal. That's one way to check your answers, but the idea here is that we're not changing the value of the fraction. We're just changing it from being written in an improper manner to being written in a proper manner. So 3 square root of 27, we rationalize the denominator, so in that way we can write this the proper way, which would be 3 square root of 27 over 27. But now, before I reduce the 3 and the 27, I want to see, can the square root of 27, can that be simplified at all? So I'm going to go over here and say, well, so we got the square root of 27. That's the same as 3 times 9, and 3 is prime. 9's not prime. That breaks down to be 3 times 3. But remember, it's a square root of 27. So for every two of the same number, I take one out. So I'm going to take out a 3. I'm left with a 3 under the radical. Now this 3 that I had originally, which is from over here, what's in purple, that 3 times the 3 that I just factored out would give me 9 square root of 3 all over 27. And now I reduce this, because now I see that 9 goes into there one time, 9 goes into 27 3 times. So my answer is 1 square root of 3, which would just be square root of 3 over 3. Remember that square root of 3, that's untouchable. I can't do anything with that because it's under the radical. And the 3 that's outside of there in the denominator, I can't reduce that any further, so that's my answer, square root of 3 over 3. Okay, I want you guys to try this first one on your own, what's in blue here, the 6 divided by the square root of 20. So use what we just talked about to simplify this, so you can pause the video and then hit play when you're ready to check to see if you got the correct answer. Okay, let's see how you did. So you should have multiplied the top and bottom by the square root of 20, giving us 6 square root of 20 over 20. The 20, I want to see if that can be simplified at all. Oops. So that breaks down to be 2 times 10. 10 breaks down to be 2 times 5. So I have a pair of 2's here. And the 5 under the radical I can't do anything with, so I have 12 square root of 5 over 20. And now I look, 12 can be reduced. 4 goes into that 3 times. 4 goes into 25 times. Now, you might not have used 4. Maybe you used 2, for example. If that was the case, you would have had 6 over 10, and 6 over 10 could still be reduced. So it's kind of nice to find a larger number, so then that way you can do less reducing or get directly to your answer. So your answer here is 3 square root of 5, all divided by 5. Now, what happens if you have a square root in the numerator and in the denominator, like this next example? Remember, I only care about what's in the denominator. The numerator can have anything we want. So I want to get rid of the square root of 6 by multiplying the top and bottom by the square root of 6. Now when I do that, the denominator, I get 6. In the numerator, however, the square root of 10 is already inside of a radical. So it's already packed away in a box. The square root of 6 is also packed away inside of a radical. It's also packed inside of a box. So I can combine these two, because I'm not putting anything inside the 6. They're already both inside of radicals. They're already both inside of boxes. So it's okay to multiply those together and get 60. Now I don't know what the square root of 60 is, so I'm going to have to simplify that. That breaks down to be 6 times 10. 6 breaks down to be 2 times 3. And 10 breaks down to be 2 times 5. So it's a square root. So for every two of the same, I get to factor one out. So I'm going to factor out a 2. But I'm left with 3 times 5, which is 15, over 6. And 2 goes into both of those. 2 goes into 2 one time and 6 3 times. My answer is square root of 15 divided by 3. And that's my final answer. Now that's what we do when we're dealing with just one term in the denominator. But what if there are 2 terms in the denominator? If there's 2 terms in the denominator, multiplying by the top and bottom by just a square root is not enough. Like if I look at this first example, if I multiply the top and bottom by the square root of 6, well, I'd have to multiply both terms in the denominator by square root of 6. Sure, that would get rid of the square root of 6 in the second term, but in the first term it would be 2 times the square root of 6. So I still have a square root in the denominator. So in order to rationalize the denominator here, you're going to multiply the top and bottom by the conjugate. So we're going to multiply the top and bottom by the conjugate of the denominator. Now we've talked about conjugates in the past. That was, again, back in chapter 6. Remember, the conjugate is where we take the opposite operation. So instead of 2 plus square root of 6, it's going to be 2 minus the square root of 6. And you multiply the top and bottom, the numerator and the denominator, by that same value. Now when you do that, Let's talk about conjugates again here for a second. Again, you don't have to write this down. I did the same thing back in chapter 6 for us to see what happens when we multiply by a conjugate. In case you've forgotten, let's look. So in this situation, I'd FOIL or multiply everything in the second set of parentheses by x. That would give me x squared. And x times 3 would give me 3x. Then I multiply everything in the second set by the negative 3. Well, negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. Now you should recognize the fact that 3x minus 3x is 0. That leaves us with x squared minus 9. So when you're multiplying by the conjugate, something unique happens. Because if I look back at the same problem, if I had multiplied just the x's together, the first terms and the last terms together, I'd get the same answer. X times x is x squared. 3 times negative 3 is negative 9. So my answer would be x squared minus 9 again. So again, when you're multiplying by the conjugate, all we're worried about is the first and last term. You're going to multiply those together, and that'll give us your answer. So, but in the numerator, we just distribute like we would normally. 4 times 2 is 8, and 4 times square root of 6 is negative, 4 square root of 6. In the denominator, we multiply by doing what we just talked about. 2 times 2 is 4. Square root of 6 times a negative square root of 6 is minus 6. And 4 minus 6 is negative 2. Let's talk about this conjugate again for a second. Whenever we multiply by the conjugate, since one is positive, one is negative, a positive times a negative is always a negative. So this will always be subtraction here. 4 minus 6 would be negative 2. The last thing we need to remember is that we're going to write your answer the answer needs to be in a plus square root of b form. Just like our imaginary numbers, when we found the conjugate of that, we had to have it in the form a plus bi. So the same thing is true here. We're going to take this fraction. This is one giant fraction. I'm going to break it up into two pieces. So I'm going to say it's 8 over negative 2 minus 4 square root of 6 over negative 2. Now 8 divided by negative 2 is negative 4. And negative 4 divided by negative 2, well, those negatives cancel each other out to make a positive. So it'll be negative 4 plus 4 divided by 2 is 2 square root of 6. There's your answer. So let's walk through this next one together and practice this last example. So for this one, we're going to take and multiply by the conjugate. 5 plus the square root of 2. Get to the top and bottom. Now, when I do the denominator, remember we only care about the first and last term. So 5 times 5 is 25. Square root of 2, or negative square root of 2 times square root of 2 is going to be negative 2, which is 23. In the numerator, I distribute the 3 through, so this is going to be 15 plus 3 square root of 2. Break that up into two pieces. 15 over 23 plus 3 square root of 2 over 23. That's prime, but that would be the proper way to write your answer. So hopefully you have an understanding of how to do some of these problems when we're dealing with two terms in the denominator. Don't forget what we did here with one term in the denominator. So with that, I'll let you work on your assignments, so good luck.